Okay, we're going to continue our discussion of trigonometric graphs, and we're going to focus on sine and cosine, okay? And we're going to expand our discussion on phase shift form from the previous video. So when we're discussing phase shift form, okay, we have a couple of different things here, and that is that we've got y equal a cosine, and then it says b times x minus d, or y equal a sine of b times x minus d. All right, in a previous video, we may have used a different value, such as k instead of or in place of b, but it's not very different. Okay, so that's why here I state that a, of course, it refers to the absolute value, is the amplitude. All right, and b is the period modifier. In this case, I also call it k. So b and k, if I say b or k, I'm referring to the same thing. Okay, and then d, of course, is the phase shift. Okay, and it moves opposite the direction of the sine. So we're going to take a look at some basic examples here, and we're going to see how we can, look at these and then analyze, if you will. So we're analyzing first, number one, they ask very simply, what is the amplitude? Well, the amplitude can be found by finding the a value, and that's the value right in front. So I can answer that very quickly. My amplitude here for number one is simply going to be 5. Okay, it is just 5. So that's the answer. But what I'm going to do is expand upon this and talk about what this looks like in phase shift form. So this is not in phase shift form necessarily because we have a 4 in front of the x, and we should just have an x by itself. So what we're going to do is we're going to divide by 4. We're going to divide all of this by 4. Okay, and so when we do that, all right, when we divide by 4, we're going to have y equal the cosine of, okay, and I'm going to call this, I'm going to put a square bracket, 4. So 4x divided by 4 is 4. I'm sorry, is 1. So we have x on the inside, and then we're going to take pi over 2, and we're also going to divide it by 4, but that's the same as multiplying it by 1/4. And so in phase shift form, this actually looks like this: cosine of 4 times x plus, and in this case, pi over 8. All right, and that's what it would look like in phase shift form. So we're going to take a look at another example, number 2. And in number 2, they ask us to find, in this case, the period. So in the first case, we were looking for amplitude, second case, period. So we are going to need to write number 2 in phase shift form. So we start off by taking a look at y, and we say, okay, well, y equal 3 times the sine. And now I notice I've got this 4 right here, so I'm going to divide again by 4. So this is actually similar, and actually the same work that we did in the last problem. It's identical. The difference is sine and cosine. All right, so x plus pi over 2, right, times 1 over 4, because we have to divide out 4. All right, we close it. And then again, it's 3 times sine, and I'm going to put the square bracket just for the sake of not having double parentheses, x plus pi over 8. Okay, so what I'm going to tell you is this one, number 2, we see that the period will be modified by our k, or our b value, which is 4. All right, so what we're going to say is the period for number 2 is 2 pi divided by 4, which is pi over 2. So this right here represents the new period. All right, this is the period of the graph. Now, if I were to ask you what is the phase shift, that's an additional question. So I'll go ahead and write that in just for the sake of, being thorough here. Well, the phase shift is given by this right here. So I'm going to tell you that this graph has actually been shifted, and it's going to be shifted pi over 8 units to the left. So it's a horizontal translation. Okay, so if you were to be asked what is the phase shift, it's moved pi over 8 units to the left. Okay, now let's go ahead and take a look. Okay, that was number 2. All right, that was number 1. Let's go ahead and take a look at number 3 down here. It says find the period y equal -3 sine of half of x minus pi over 2. Okay, so this one is going to work out very similarly. Okay, so y equals -3 sine. I'm going to put my square bracket, okay, and I do have to divide out that 1/2. Okay, so the 1/2 is going to come out, and on the inside I'm going to have x minus pi over 2 divided by 1/2, which is the same as multiplying by the reciprocal, 2 over 1. Okay, I always tell my students when dividing fractions, always remember to KFC. All right, and so what ends up happening here is these 2's cross out, and our phase shift is a little bit more apparent and obvious. Okay, so our new function, well, it's not our new function, it's the same one, it's just reimagined. All right, is 1/2 -3 sine, and then on a square bracket 1/2 of x minus pi. All right, so we were asked in this case to find the period, so that's not a big deal. All right, the period is simply going to be 2 pi divided by our period modifier here, 1/2. So divided by 1/2, all right, which is the same as 2 pi being multiplied by 2 over 1, which is 4 pi. So our new period is 4 pi. We've extended the period. What this means implicitly is that since we've extended the period, we have decreased the frequency of the oscillation. That means that it will repeat itself less frequently because we've extended the period. So there is a correlation or relation anyway that it's inversely proportional, frequency and period. They're inversely proportional. And you'll find that out in a later section of this chapter, surely. All right, so the period is there 4 pi, and just for good measure, let's go ahead and finish off by talking about the phase shift for this graph. And the phase shift can be found by analyzing this right here. Well, this tells us x minus pi. Remember, it moves opposite of the sign. That means this moves pi units to the right. Okay, so that is the direction that this graph is moving in. All right, so really, other than that, there's nothing to it. All right, we've found amplitude very simply. We found period very simply. And we have adjusted these and written them in their phase shift form. So, as always, I hope this video was helpful. And remember, like and subscribe.